Testing. 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 All right, we're live. Okay. So, today we're going to be continuing our NeRF from scratch project with ChatGPT. Back on our Linux, have internet is good to go. You're just joining. Everything we do here, all this code can be found on a GitHub repo. So on my GitHub profile, there's the go here, NeRF Ito, little NeRF in Spanish, and yeah, it contains basically code. And we actually go ahead and link the new code stream. Shift G opens up the GitHub commit panel in VS Code, and we're going to commit this. We're going to say add go back to GitHub, fresh, see that the README was updated now. That's one of the commits. So our commit workflow is working perfectly. So go back into our terminal here and let's add pyenv activate. So you see now in our terminal we have this little veto in parentheses. Pyenv is a Python environment and allows you to kind of keep your Python dependencies separate for different projects. So we have a Python environment that has all of our Python dependencies, and if you want to have the same environment in your system, you can use this requirements.txt file, and you can basically install this command. Install the dependencies locally with this command. Pip install-r requirements.txt. And that's okay, so a couple things that we wanted to do today. So today we wanted to get into the actual ray marching part of the NeRF algorithm, and then the batching the inference calls. Yeah, and then maybe going into, so if you recall, last time we basically created a Blender script that went ahead and created synthetic data for us for training this NeRF. But now, and we also created this dataset class. This is a torch, PyTorch kind of abstraction, right? A class is kind of like a struct. It's basically an organized it's a way to organize data of a specific type. So there's different properties and so on, but then there's also these functions that allow you to take a synthetic dataset object and get, for example, the length of the dataset or an individual item from the dataset and so on. So one of the to-dos that I had here is that so getting items, so you want to get a single item from this dataset. What this is doing now is it takes an image, or it takes a file path to an image, and then it opens that image, converts it to RGB, finds the theta and phi, which is basically parameterize the ray that intersects, or that the ray that goes through to that camera position, basically. But the problem is this is theta and phi for the we need theta and phi for each ray. Right. So we're going to need a couple different things, right? We're going to need calculate the theta and phi for each ray. Then we're going to need return the image pixel value for each ray, right? So the image composed of, there's some width and some height image, and at each width and height there's going to be a pixel, and within each pixel there's going to be a color. That pixel is going to have a single RGB color, and there's going to be a single ray for that pixel. The need additional properties here. Why don't we add a width, height? There's not anywhere near 512 by 512. I think 28 by 128 is what we do. So for the width and the height of the image, have additional x in range width, and then for y in height. And we're not going to be keeping track of files here. We're basically have a phrase. This is going to our data set, the discrete unit, a single data point in this data set is going to be a ray. But now I'm thinking, do we want this to be part of the dataset object, or do we want this to be in our training script? Why don't we go ahead and maybe look a little bit at the actual training script here. We find a better place to so since the last time, basically what have here is we're loading 3 different data sets. Of course, we're going to have our train, we're going to have our validation, and we're going to have our test. What this is going to be different images of the same scene. Here we're creating our model, which we define in our NeRF here. It's just a So there's a couple different parameters for our model. We have number of layers, number of hidden units per layer, the input size, and the output size. One thing is, if from the paper yesterday, we noticed that they had leaky ReLUs, so we can ReLU. Why don't we go ahead and ReLU? Got a bool. ReLU if self dot ReLU GitHub Copilot makes it very easy. Make these little. I wonder if there's got back to our train. Okay, so we have our NeRF model. We have actually and we'll feed that into org. Have a kind of standard atom optimizer, and then have a loss function. So we didn't have the loss function before, so we where could we put? We could put this in the dataset file here, model file. It almost makes sense directly here. So why don't we go ahead and actually in run ChatGPT. So we're going to ask write PyTorch loss for me that takes the L2 loss between a predicted pixel value and ground truth pixel value. This loss function will be evaluated for each ray in a ray bundle as part of a copy that just in like that. Okay, so it's making it a little separate function here. This basically just gave us an L2 loss. Super. Okay, actually, here you go. The context of NeRF, you may want to compute the loss for each ray individually, and then the average losses to get the final loss for the whole bundle. Here's how you compute it by looping over each. Okay, so I mean, all it did is basically just add this little for loop here. Okay. Copy that. that there. I'll put this here. And the reason I'm kind of working on the loss right now is that go through your actual training process, and that'll make it easier for you to understand what the dataset loader class here should return. Right? So copy paste. Sure that 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 loss lock in Redux by here's where you actually NeRF L2 loss. So what are the outputs and what are the labels? So in this right here, we need predictions targets, where the predictions are pixels and the target, or the predictions are pixels, targets are 1x3 vectors. So we need the labels to be coming out in 1x3 vectors, and we need the outputs of the model to be coming out in 1x3 vectors, right? So if we go back to our model, the output size is 4, right? Because it has a color and then also an opacity, right? And the NeRF model is evaluated at each point, and there's multiple points for a given array. So on the outputs here, color for a pixel for a single array. The label should also be a color of round. I need to be that. And the inputs into the model, 5. The input to the model is going to be X, Y, Z position of a point inside the volume, and then the theta and the phi. So these are correct, right? The model, you're going to get X, batch size 5. Combine the phi sample point nations. Let's actually see what Copilot is experiencing. puts dot cat, and so we pause here. As we have shotgun called a geometry. All of our geometry stuff. And a list of arrays. Get a list of arrays for a sample points within a array. You sample one. This was actually get points. Get a list of volume. Okay. This is actually the point in get point. We're going to volume object from object. Object. Those are going to be here. Our get. So for a given camera volume, we're going to get all the points, which means that to me, what that means is that this train data loader class should actually not be returned in phi. What it needs to actually return is image camera, and then so image camera by combined by sample point by and sample models. What model input? Calculate that. Right. This is your 5-dimensional input into your actual model. And then your model is going to output something that's of dimension, batch size, right? Then the final pixel value for each output right, and this is the ray marching, so you actually and you write a PyTorch operation for me that value of a pixel or a ray that reverses volume. Algorithm is called ray marching, and as you along the ray, the opacity of sample point ray is a final value. So I think what I'm trying to do here with ChatGPT is like, so if you just give it this, it's not gonna really know what's going on. So like the more, like sometimes if you just keep explaining and you just give it more context about what it's actually doing, right? So here you go. Sure, here's an example of how you can implement ray marching in PyTorch. So initialize the output shape. You have rays.shape and then volume.shape. Image is torch.zeros, okay. Find a function to get the value and the gradient of the volume at the given position. Position.round.lamp. But this is not, this is what your neural net is doing. So I don't think you need that. Iterate over each ray. This seems fine. Value rad equals sample the ray position. Image ij plus equals value times step size. I think this makes sense. Okay, this is just straight nonsense. Okay. Yeah, this is more complicated than we need. I think it's getting confused. It's kind of giving you a mishmash of like 10 different more complicated ray marching implementations. Like in our case, you don't need to define a function to get the value at a given position. That's literally what the neural net that we're training to do is. And the step size doesn't matter here either, right? Basically, in our case, since our network is just outputting the color and opacity, all we basically need to do is just basically incrementally add all of them together. So I do like this double for loop here, though. Say for output or for arrays in change batch size, which insert outputs dot shape, and then basically the batch dimension of the shape should be the batch size, right? And in our case, we're basically going to be doing one ray. And then for within each ray, we're going to have a number of samples. The way this is actually going to point in the range of the batch size, where each batch represents one batch. Okay. So output of the model, right? Output is n, right? Where n is the number of samples. Then it's going to be 5, because that's the output size, right? And output of point all, first one is going to be opacity, that opacity, color, the rest of them, right? It's actually by 4. The first one is going to be opacity, the next, and the way that we're doing this, the points along this ray are always going to be ordered, right? So what we can say is that final color or predicted value that value as you go through each plus equal color of the next point times 1 minus opacity. but once capacity share no more color at something, but we can go back to now that you have the predicted value. The value color for a don't actually like that anyway. Actually, are lost direct. Actually, quite. It's okay. So ground truth pixel value, what needs to come out here? And if you're getting the ground truth pixel value, you also need position of that pixel image. So X and Y. X, Y. Backwards. Up dot step. Then the okay, so now that we've gone through this loss function and kind of how we're going to eventually get the loss from the ground truth pixel value and the predicted pixel value, we can actually go back into our scene and then also our data set geometry classes, and we can think about what more information, right? Because right now, the information that we're writing into the actual data set, which is in this case we're writing it directly as the name of the file. We're only saving the theta and the phi, right? But we also need the camera position. It's going to be a little bit more complex. I think we might want a CSV file. I don't want to have to write a CSV file though. Good thing we have ChatGPT. Write Python code at writes line separate values file. File path, and then we have a path. Opening of the actual file is going to happen better to open the CSV file and then do everything, or is it better to open the CSV file every time? Better to open the file and open the CSV file. Right row. I. Better object. What do we need? Orient. By 3. Orient with, I think really the one camera position to be right. Python code for me that takes by 3 array that comes out of Python all, and it separate. See if ChatGPT write some boilerplate for it. Okay, so I mean, all it really did is this list row for row in R. Oh. If row of row start with the append X. That. And but we went ahead and modified our script, our Python script that uses Blender to move a camera around an object and basically the image of that, and then also the orientation, and now the camera position as well, data and phi, which are the basically back to that. So now we're going to go back into our dataset object, which is going to consume this. We don't need this pattern anymore. Actually, what we're going to back into our scene, and the file name for this is going to be a random ID. Or UID is like basically allows you to create file path equals dot or dot hex g save. Yep, that is correct. Yes. And actually, file name. Row of data that we write into the file. File path to is going to image. So our row now has the file name, it has the position, it has the camera location, and it has the in the fly. So when we're reading this in with our dataset object, we need root directory. We also need directory is going to be, we're also going to see file path in the string. We're actually no longer going to need a regex in that. Image width, image height, and local passing focus. So make a new chat here. Ask ChatGPT. Write Python code for that following information row in a file. Code below is that we write the rows. It writes it to an eCSV file. You only need this first part here. Not in here. File path. Then you make this object, and then you iterate this. Row in each row from the input CSV file, get the image file path, file name, get the camera position, the camera orient. Actually going to be 9 numbers. B13. Okay, so now the question is, do we want to do this here in the initialization of this object, or do we want to do this here when we actually get the item? So if you do it in the initialization of the object, right, you read through and you basically create this array list. The problem is that then that array list, you're going to have that in memory the whole time. So if this data set gets really big, it's going to kind of get out of control. You do it here in the get item function. Now you're going to be doing this every time you get an item from the function. So if you have to open the CSV file, now you're opening a CSV file potentially thousands of times. So I think what we're going to do is we're going to do it here in the initialization. So yeah, let's. This is a terrible name. What is a good name for this? This is one row of camera or camera, or actually even better, let's or snapshot. Snapshot. So here, self dot snapshots plus equal row of this stuff. Okay. So now the length of our data set is actually going to be snapshots. And it's actually going to be more than that because snapshot, there's however many pixels there are width and height. But we're not going to actually get those until okay. So this get item function, which is called whenever you're loading this data set by Torch training or you're testing or whatever it is, give you an index. So that index it correspond to a single snapshot. That snapshot, we need to break it down. Actual this here. Go ahead and place row with snapshots. I think H here, and we row snapshot here, and start from this one, and then we replace. We now have all the information that we want in the specific format that we want, or not in the format yet, but we have the position, we have the orientation. Makes it a little. Okay. So now we actually need to open the image. Right, so file name. In the image path, we're going to B, and then now actually every pixel or x in self dot image width. Sorry. Width. Or y dot image height. That's going to be the pixel value. So this is going to be, remember in our training, we wanted the ground truth pixel value. So that's where we're at. Why don't we just call it pixel? Makes we're actually going to ask, can you yield as a return in a PyTorch dataset classes item function? Yes, it is possible to use the yield keyword as a return in the getItem method of a PyTorch dataset class, but it would not be the typical usage. The getItem method is used to retrieve a single item from the dataset at a specific index, and it typically returns a tuple of the form inputs targets. This method is called each time a mini batch is loaded for training. By default, this method should return the item directly, but you use yield to make this function a generator and an indicator. Okay, so it says would not be the typical use. So I think what we're going to do instead is we could basically we can do some mod math here, right? You could basically say we want, if you want the 700th index of this data set, what does that correspond? So we're going to need x and a y. Here we're going to calculate x, y pixel x is index divided by self, and then pixel y that, but for that actually snapshot x. That's going to be x mod uh, mod times image height. So this is going to tell you what snapshot it is. What snapshot index what pixel x y coordinates versus first you get the snapshot index, and that'll tell you which snapshot to use. Then you get the pixel x and the y by basically current index minus snapshot index right. This pixel index x mod self.image width, and then y actually height here, index mod image width pixel x double division height. Something okay. But once you get those, you should have a pixel y, you should have x. You now have the image file name, you have the position, the camera, and the phi. You can open up the image, you get the actual pixel value because you have the x and y. And now we can return all of these. It's going to be a relatively crowded return value here. We have pixel value, wonder if I can object with a PyTorch dataset class. I feel like that should make it a little parse. Okay. Okay. The pixel value. All right. We're going to and we're going to return. And we're also going to return the phi. So that means that when here, this is going out, and here our object with east. Okay. Again, if we go into our geometry, there, except now whatever is what our camera orientation. Then let's extract those. Well, extract the data point data phi equals d phi. Get points in that are same. Here, our ground truth pixel value, this is where we're going to get our D. Actually watching. But we've done a bunch of stuff here, so why don't we actually go ahead and model add the leak. In our data set, our detail set, commit that. Okay. B guys, I don't know if anybody even watches these. Getting a little. Pretty much done with everything now. We just kind of need to bug this and eventually collect more data and so on. But this whole stream, at least the streams related to the project, aren't super popular, so I'll just end tomorrow. Okay, well, that submitted this. It's here in Nerfito if you guys want to see it. Maybe we go back to this. Not. But not. Thank you for listening. And I'll try to find a paper or an article or something a little bit more interesting. It's me.